Alright, so one of the other forum members, Jeremy there, Zombies, can't wrap his head around what I'm trying to explain here. So basically, during current sensor calibration, and that's what I'm using here, I'm just using that to test because it puts some current through the windings, and then I can prove whether my switching's looking good or not. And I've actually found it wasn't, so now I'm sorting those issues out. What I did was I actually found that when the high side turns on, I was getting a ring, but I wasn't actually measuring the high side gate. I was actually measuring the low side gate while watching the emitter and collector on the low side, which is basically negative to the phase wire. And when the negative to phase wire would go up, that would mean the high side was turning on if I saw a ring. But I also had another event, which was actually when the low side was turning off, causing a spike. Those are two separate, different things. Now, Jeremy was trying to understand, he doesn't think that this phase should turn the low side on the same phase and the high side on right after on the same phase. But these two traces here are actually from that. You can actually see that it actually turns the high side on right after the low side. So if you scroll across, you know, there's a little dead time there, a little delay, whatever. So I'll bring this over. And that's essentially our dead time, which is programmed at 2 microseconds. And there you go, it's at 2 microseconds. Now if we scroll this, sorry, wrong button. I'll switch, scroll this over. We look there, it's still basically like right on the money for our dead time. So what I'm actually going to do is I'll actually try and prove this in real time. So I have both scope probes hooked to, which is a shared ground between the Arduino and the brain, so basically brain ground. And then I'm going to probe both scope probes on phase 1, high and low side current limiting resistors. And then I'm going to get that signal there. And you'll see here, I'm going to push B for current sensor calibration. And this is going to give me this. So I'm going to try and do it with one hand. It's going to be a little tricky. There's one in there. Let's set the phone down for a second. Okay, you can see in there, it's hard to see with the camera, the phone. I'm on phase 1, high and low side. Just make sure I have a good bite there. So there's phase 1. So I'm going to push B over here, which is, it's actually on B. I'm going to push enter, and you can see it right there. And then I'll push run stop. So now it's froze it. And what it does is it actually tries to pulse them. It actually uses the whole controller. It does the synchronous, I don't even know how you pronounce that word, rectification, which actually uses the whole, all 3 H bridges to pulse, to get current to flow where it wants to flow. So now we'll zoom this out. We'll look right there. And from basically, I'm going to go like this. So basically right there. Whoops. So it's your 2 microseconds dead time. Now we'll bring that across. And 2 microseconds dead time. Bring that across. 2 microseconds dead time. It's always doing that. Always. So basically, what I was trying to explain before was I had events where the low side was turning off and then the high side was turning on. The high side was the one that was trying to produce the current. The low side was not actually trying to produce current. And when the high side turned on, it caused the ring. And that's how I diagnosed my problem, seeing that it was switching too fast. Because the low side, when it was turning on under load, it would ring, but it would ring such a small amount. It was really hard to see. And the desaturation detection would actually kick in because the emitter, which is DC negative, would bounce up and then down. And when it bounced down really fast, that would actually kick the desaturation detection and trigger it and shut everything down. So anyways, you can see it right there. Zoom out again. It's always pulsing up and down on both of them.